chapter we are looking at the truss. Truss is a structure, right? A structure that is composed of several members. We have different type of trusses. These are some of the well known that are used in housing structure, in bridges. As you see, these are a member. Each one is a member of the truss. This is one member. This from here to here is one member. So we have a lot of these, members. Then they're going to make a structure to carry forces. It can be a roof. This can be a roof. This one, or this can be a bridge truss, right? So our main goal is to determine the force developed in each member. So let's say each, depending on the material you use, they say this member is gonna, it can hold um, 1 kips, right? Or let's say 100 pounds. Okay, so this is the threshold. You're gonna make sure you calculate the load and then see whether that member is close to that threshold or not, right? So the idea is to determine how much load each member is going to carry, right? So to find that the forces for each member. In this class, we will neglect the weight of individual member. So we are not including those weight in the calculation. The member are joined by a smooth pin. So we have, for example, this is one member, this is another member, then we have pin. So if there is no member here to make a triangle, what happens? So this can rotate, right? Pin can restrict in xy direction, not rotation. It doesn't restrict the rotation. Okay, so because of that assumption, we can tell the forces that are in each member, the truss member, is going to be either in tension mode or in compression, because there is no moment. In other topic, which is frame, we will have a moment. But in this one, the truss, remember, in the truss, we have only tensile or compressive type of forces. We show tensile tension with T and compressive force with the C. So not only we need to determine the magnitude, we also need to say whether the force is going to be compressive or tensile in the calculation. So we have to show whether tension or compression in the calculation. This one, we have 3-member. It's a wind, right? So this one is a 3-member. 1 member here, right? 1 member here, 1 here, and then we have a pin at this point. This is also pin. This one is also pin. This is pin, but the support, in this point B, has a roller support. What type of reaction do we have here? How many reaction? 1 reaction in this, y direction, right? Perpendicular to the surface. Always remember, perpendicular to the surface. If the surface was like that, so it should be perpendicular to this surface, like that. The force will be, reaction force is going to be like that. Correct? Okay. So this can be, considered as rigid. But remember, when we say rigid, it means, the part is not gonna, buckle. It's gonna be sturdy. The part may stretch. It may, shorten depending, the type of force. That compressive force, it's gonna make, the part shrink, right? It's compressing, the part. Or the tensile force is gonna stretch. Then we have elongation. This is the topic that is related to mechanical materials, right? In the next course. Make sure you take, for this class, you get a grade C or better. Because that is the prereq for the mechanical material for the next course. If you get, C minus, they will not accept it. You have to take, static again. So don't think just, passing this course. You have to get, C from this course in order to be able to take the mechanical material. Okay? So back to that topic. Sometimes, we add more member like this one, so we make a triangle. So this is, somehow rigid, and once you add this one, so you're restricting that part further. So you can add, elements or more elements to this structure, depending on the type of structure you plan to do, right? Make. So there are some, our objective was to determine the force in each part, in each member. Here we have 3 members, right? We have 2 different methods. The first method is called, method of joints. That method, what we need to do, we have to look at each joint. For example, we focus on this joint, and then find the forces in each, in that member. For example, in point BA, what are the members do we have? We have a reaction, support here, right? So this support is going to have 2 forces, and then if we cut this, this point A from the structure, we will have 1 here, 1 there, right? So it will show you 4 forces. The free body diagram for joint A. If we cut this one from the entire section, so you have, let's say A vertical, you have A, let's show this way, because in that one we have a member, A X, and what else? We have a member AC. And for AC, we should show a force. You can show it like that, AC. And what is AC? AC is the member, right? So you can also show it like that. When you, in this joint, you show AC in this direction, this is a member, right, itself, a joint here. I'm just, showing the free body diagram for each one. So this is the free body diagram for this joint. And now this is the free body diagram for this part alone. And then I'm gonna plot free body diagram for that joint C. CY, right? And then this is BC. BC. So this is a free body diagram for joint C, free body diagram for element AC, and free body diagram for joint A. Okay? So once you calculate, you draw this free body diagram, you find the AC, you can transfer it to here, you say, what is this one showing? These two are showing a stretching force, right? So whenever you have a force coming from that joint, this the other direction coming out of that point, that is going to show you a tensile or tension load, right? When you have a joint, let's say we have a joint, let's B, and my force, my member has this force. I have to reverse the direction on the member, so the internal force is going to be like this one. It's compressing, is shrinking the part. So this is going to be a compressive load. So whenever the force is going through the point, joint, that is C. Coming out of joint is going to be tension. These two point, remember. Coming out of that joint shows you a T. Coming to the joint shows you a C. Why sometimes it's important? Because you don't need to plot this part with that concept. You would know this is going to be compressive or tensile. Otherwise, you have to plot it and then look at it, understand it, whether it is compressive or tensile, right? Coming out, tensile, going to the point C, that is going to be compressive. Make sense? Sometimes initially, you draw a tension load, and then you find, at the end of the problem, you find the value that you got is negative. The value should be positive, right? If you had a correct, direction. If you find, negative value, let's say I found this one was -15, then it tells me the direction I picked initially, which was tension, it was wrong. So I have to reverse it and show it this is compressive. This is not tension. Let's do one problem, then you will have a better understanding how to do this type of problem. So in this way, what we do, we have to determine the force in each member of the truss, and that is called method of joint. We focus on each joint. The idea is to find the force in each member. So if you, let's say, you do a method of joint at this point, and then you do a method of joint here. So once you do here, what are the members that you can find? A and B, correct? You can find the value or the force, internal force in the AB and internal force in AC, right? This is the first step. Once you go to the point C, joint C, you do that problem. So that is going to give you AC. You have it already coming from this joint, and then you will find also BC from this joint. Do I need to go further? No, right?
because I got this one, right? I have this one, and I have this one. I don't need to go to join this B anymore. The idea, the concept was to find the force in each member. So by solving this two, we are fine. We don't need to go to the joint B. So let's do this problem. This one has a force here, right? Now we're gonna find the force in this, three members. Before we started, finding the force in each member, what do we need? It's as you see, we have a support. We have two supports, one support here, one support there, right? We need to find the reaction from the equilibrium. The previous chapter, we have to find the force here and force in this, A. Draw the free body diagram. So I have this 500, right? This is 2 meters, this is 2 meters. So I'm plotting this one, B, X, no, B, Y. This one, I'm gonna draw this direction, B, no, it should be A, Y, and this is point C. I should have C, Y. How about this one? This one, I'm drawing this direction, and this is A, X. Okay, we have three unknowns. From the previous topic, we can easily find these forces, right? We have three tools: sigma, summation of forces in the x direction, summation of force in y direction, or summation of moment. I think this is better summation of force in x direction. It should be 0, right? This is the equation we know. What do we have? We have 500. Let's 500 positive. This is the force, right? What else? I have this one, AX minus AX. That is 0. So my AX is 500. So we got the positive value. That means the direction I picked initially, that is correct. So I should continue. This is 500. Make sense?
You have this 500 minus AX.
Yeah, 500. This is 500. And my AX is in this direction. I drew this direction, so it's a negative, right? This is the standard beset for x's.
Right. I get that. I'm just saying, like, when you have AX equals 0, and then you have AX equals 500.
Yes, what happened here? 500 minus AX, 0. So I move this one, as I said before, when you move one term to the other side of the equal, it's going to change, the sign. So 500 is going to stay, AX, like that.
Yeah, I understand.
So I just reversed it.
Yes, sir. Yeah, I misunderstood.
What else? So we got this one, now we want to find AY. AY, if you do AY, you see you have two unknowns here, right? In that summation of force in y direction. Do you have any other solution? Huh? Sigma f y 0?
Yeah.
But we can do it, but in that equation, we will have two unknowns. One equation, two unknowns.
We use the moment.
Moment, yes. Moment about which point do you recommend?
A.
Yes, we can use that one, moment about point A. So if we use this one, what we will have 500, right? It's gonna make clockwise in moment. So it should be negative 500 FD, right? Times displacement, the D. D vertical distance is 2 meters. And then we have sigma y, and that is also making negative moment, right? Negative moment, and I draw this way, so it's gonna be 2 f times 2. I don't have anything else. So what happened if we do this one? We have 1,000. This one goes on the other side, positive. Sigma y times 2. I will have sigma y minus 500. That means this direction I picked is not correct. I should change it. I can change right now. So going forward, I use this direction. I say, minus 500, or in this direction, I say positive 500. So when you write, positive 500, that means this is the right, correct, direction.
So one more time, why is it wrong? I'm a little confused on why.
Because we got a negative value. Negative value, always the magnitude is positive.
Okay.
Magnitude, right? We pick the direction in the calculation. We said it, it's making, negative clockwise moment. So we brought that, moment sign already here. So this is a moment sign, and this should be positive. We are always using a positive magnitude. Magnitude is positive. This one, you see, even it is in this direction, right? We wrote 500. Why we are not writing negative? Because this is the magnitude. Direction, we are showing it. This represents the negative. The direction, this one is representing the direction. Negative. This is negative. Okay, so this is positive now. What else? So we got this one. Now we can find AY. Now I can easily change it because this is going this direction. This should be the other opposite, right? So I can before I go for the next part, I'm gonna draw it this way. So Fy 0. What do I have? I have this one. I have this one, right? 500 minus, this is going down, so I bring that negative here. 0. Ay is 500. So I can write 500 here. Again, this is going down, right? So this means, this is negative force. But I don't have that negative sign there because I'm showing it. With this arrow. Arrow shows the negative. So, so far what we did, chapter 4. Nothing new. We just did, we just found the forces on the reaction, on the supports. Now we want to do a new thing, which is finding the forces in the member. Okay, So this is your, you have to decide which point you want to start. Should I go directly here? If I go there, what do I have? I have one noun force, right? This is another unknown, right? This is unknown. I can do that one. You can, you have two unknown, you can do it. How about this one? Point C. I have one noun force, right? Where is it? This one. I have two unknown. How about this one? Point A. Point A is going to be easier. It does not have a slope, right? You don't deal with the sine, cosine. So let's go with point A. So again, what is concept? What do you want to do? What is the goal? Any idea?
Find
The goal.
force inside the structure.
Huh?
The force inside like the structure itself.
Yeah, forces, internal force in each member. So that's where we want to get. Okay. So we start with the point joint A. Draw, you have to draw this free body diagram for each joint that you want to start. So this is joint A. Draw it, all of them. And then now we need to draw force member. The force on the member has to be directly coming from this member, right? It has to be in that direction. So you decide whether it's going to be going to the member, going to the joint, or coming from the joint. So once I have this, forces, the reaction, I think, my AC member is going to be in the opposite direction because of the Newton law, right? If I plot it in this direction, my joint is going to move. It's not going to be stable. So I draw the other direction opposite to make it stable. And what do I call it? You can call it, with this member, AC, force AC. Okay? Yes?
So basically what you're saying is the force inside the beam will be the opposite of the force applied to the direction lines. Is that what you're saying?
Right. So when you cut it, it's called internal force. You don't see it. But once you bring it back together, you weld it, let's say you weld it, then those forces have to be disappeared. They have to cancel each other. For example, I have this one, right? And you pull it in your direction, I pull it this way. What's happening, we don't see the forces, but if we put a scale here, something force measurement, it tells us we are pulling about 500, 5 Newton, 5 pounds, right? But what are the forces? The force, if we remove it, from my hand and from your hand, 500, 5 pounds is going to be going this way, right? 5 pounds is going to be going that way. So that makes it stretch, right? But I was pulling it, right? So my force is going to go this way. On the member, we should show it, this direction. So they have to cancel each other. They make it 0. So let me draw it, This is me, right? This is Christopher. And we have a rope. Let's say we have a beam. He's applying a pressure, tension load. It's pulling it this direction. Now we want to cut it. We want to cut from here, and then see what happens. If we cut it, So we have this beam. Christopher is here. We want to analyze, how much force he's applying. He's pulling, right? So it's going to be like that. So this is going to be a stretch, right? This is me. It has to be the same amount. Once you bring it together, so they cancel each other. This is 5. So then you bring hands together, this 5 by this 5 is going to be canceled, the same thing here. But the internal force, this is one way to imagine it, right? Does it answer your question? Okay, so here we have AC. What should I call this member, this force? AD. Remember, if you look at these, joint and then name those forces, correctly. If you know, for example, this force, I'm gonna draw it, this direction, AC. This is gonna mess up your problem completely. So make sure you're the right, name. Okay. So this is one free body diagram looking at this joint. That's why we call it method of joint. We're gonna focus joint by joint until we have all the members. So when we find this force, that shows me the force, the internal force of this one. And once I find this, AB, this is gonna be the internal force here. It doesn't matter, I go from this point to find AB, or I go this point to find AB. Either one, it's gonna be correct. So I have all the number here, I can erase this part. So in the method of joint, you use only 2 equations, no moment. You know why? Because we are looking at the joint. In the joint, there is no moment. So easy, only use this equation. If I see you use moment equation, that means you didn't understand. In the method of joint, once you find the reaction, then you are all set with the moment. Don't use moment after that. Okay, use only these 2 equations for each member. So point A, right? What do I have? Fx, AC, it's going this way, minus AX, which is AC 500, right? 0. My AC is 500. Easy. Next, Fy. I have AB in the going upward, and then I have 500 going downward, 0. So my AB is 500. Okay? So now you tell me this 500, is it, you have to write T or C at the end of that one. AB is going this way, right? Is coming out of that point. Is it, tension or compressive? Tension, right? So put, both of them are the same. Put T, that means, tension. AB has 500, tension load. You can put the, first N, and then unit, you don't forget unit. little space, you can write, tension, or you can just show, T. That represent tension. Okay, what is next? We have two member. Now we can go to this point to find this member, right? We can go to this point to find this member. So this is gonna be up to you. You pick. I'm gonna go with let's go point, B. Draw the free body diagram for B. B has this force, right? It already has it, 500, and this is B. And okay, for this one, I already know the AB. What is, the direction I should show? Representing a, B, A, or you can also write, AB. Downward or upward? Down, right? Because we said this is the tension and should be coming from the point. Okay, so this is, what is this force? B, C. And now based on this forces we have, this is a static. So the part, every joint has to be equilibrium, right? Every part, every joint. So this one, should I draw, my force in BC this direction or in this direction? Which one? Coming out or coming, going to the point? Going in. Because that, is gonna cancel these two forces, right? This is how you can make that joint stationary. Otherwise, it's gonna move. So this is some engineering sense. You can draw it this way, and then finally you will find, oh, my force is negative, my BC is negative. Then you have to go back and change the direction. That is all right. If you sometimes you don't know, but this is clear because you have this one, you have this one. You can easily say that my BC has to be going to the point G, B. So I can use only probably one to find BA. We have BA 500. Fx is 0. I have 500 here, right? This one, and my BC has, angle 45, right? This one is 45. If I extend it, it's going to be again, 45, right? So, what is the x component of the BC? BC is going, to the left, should be negative BC times cosine 45. That is 0. That is the only forces in x direction. So 500, I'll take this one to the other side, positive value, then cosine 45. Cosine 45 is BC. $707. BC is 707.1, and that is should be C, right? Because it's going to this point, should be C. So do we need to continue? You have to look. We got this member, we got this one, we got this one. We had 3 members, we have all the members. That's all. You don't need to go to point C. Any question? Next example. So in the method of join, what do we use? We use only, remember, we use only this equation. For the joints. For the joint, use only these two. Okay? Determine the forces acting on all members. We have, how many members do we have here? 4? 5, 4.
That's 5.
AB is 1, right? AD, BD, CD, CD, and CB. There are 5 members. Okay. Now we first, what is the first step to find support reactions? Free body diagram for the structure. B is this 3. D, C, A. Okay, in point A we have pin, so we can show this is my up. AX, AY. And this one, CY. Okay? In order to find, CY, you can use the moment, moment about point A, 0, right? I'm gonna find, the CY. So I pick this point, and then summation of moments around that point should be 0. So I have only this force and this 2, this one. 3 force times distance. What is the distance here with respect to point A? Right, 2 meters. And that is negative, right? Clockwise, negative. CY, it's going to be positive. It's going to make counterclockwise. What is the distance? 2 plus 2, 4, right? 0. And my CY will be, this is 6 divided by 4, 1.5. 1.5 kN. Okay, so I can write it here, 1.5.
Professor, for 4, did you just get the 4 from 2 plus 2, correct?
Oh, yes, yes,
Yes.
the distance, yeah.
Okay.
Because my y was here, so distance is here.
I was just making sure. Thank you.
Next is, so we have this one. We can use a summation of fx now. Fx is, we have 3 over there, right? And this ax minus ax, 0, my ax is 3, kn. I write it, 3 in this one. Then next is fy0. I have ay minus cy positive, which is 1.5. That's it. My ay is 1.5. This is 1.5. So I have all the unknown support, right, forces. What's next? Now we need to pick a point. Can I start here? This is a good start?
No.
No, a lot of unknown. This one. Is it good start? It's gonna be a little tricky. You see, there is one force going here. You have one force. This 3 members, 3 equations. It's gonna be 3 unknowns. It's a little difficult. It's very difficult.
Can you use method of joints then, since we have more than 2 unknowns?
Yeah, you cannot solve it. You have 3 unknown. You cannot start with point B. We can go with the point A or point C. Let's go with point C. Point C, we have this one, 1.5. I'm going to draw it this way. So what is this one? DC, right? And this is BC. So what are the equation I can use? Only fx and fy. Sometimes if you tackle a joint, it's fine. If you cannot solve it, go to another joint. Don't worry. Go to another joint and then start from that one. So if I use fx, I have bx, bc. bc is going this way, so I can. This is my line. What is this angle? 45. So this, if I go that way, this is going to be 45 too. This is 45. So BC, I'm using the top one. BC times cosine 45. Okay? And then DC, what is the angle for DC? DC is here, right? 30 degrees. When you draw this direction, it's gonna be 30 degrees, right? Let me draw it here. Agree? So then my DC is cosine 30. Do I have another one? No. 0. So what I have here, I have this equation with two unknown. These are ratio, we can find the ratio. This one is cosine 30 is, I think, this number. So I cannot solve it, right? I need to go more. Use the other equation. Fy 0. So that gives me another equation with two unknown, and then I have two unknown, two equation. Remember, at the beginning of the semester, I showed you how to use, your calculator, engineering calculator, to solve two unknown. When you have two equations, two unknown. I already also, there was I remember it was, if you forgot, so this is, no, it's not here. You cannot substitute. Duplicate. Vector elimination. So this is something that you can do manually, right? I put in the video. There were two methods: elimination method and substitution method. You can use those manual type of solving the problem, or use this tutorial. This is that shows you how to use calculator, your engineering calculator, to solve this problem. Okay, so we need to another Fy is 0. Okay, so BC times sine 45. Is it negative or positive? Now we are looking at the Fy. So BC, this is BC, and we drew the direction this way, right? So it should be negative because the projection is going to be in this. So minus BC. And then DC also should be negative. DC sine 30. What else? We have 1.5, right? This is the force that we calculated before, plus 1.5 equals 0. So BC times this minus DC sine 30 is half. This is 1.5. So we have two equations. So I want somebody to solve this problem. You remember in the calculator you have to make a matrix. Put the BC is right here, BC. BC factors are going to be this one, and this is minus, and that one is minus. This is 0. It's better to use this one. That calculator you have to use plus 1.5. when, you know, it should be like that. Okay. Let me see if I have the answer. Somewhere. If you find the answer, let me know, because I'm keep looking at the. Let me do it. I cannot find that. This is BC. This is BC. And what happens? You know, I can cancel these two by each other. And what I have left is this one. -1 BC. So, and DC. Times 2 divided by this by this. This is my DC. Let me use the calculator to divided by so the answer DC is minus. That is giving me minus number. What does it mean? 4.9. So it means, you know, this direction was incorrect. You know, I can change it. But let me finish, you know, let me find BC as well. So this is BC minus this is 4.40. So this one this goes the other direction. Positive. This one is gone by this. So what I have is what this by okay, multiply by 1.5 5.0. Okay, my BC 5.0. I use manual calculation to find it, but remember you use calculator. In the exam you don't have time. Okay, make sure you are quick to use the engineering calculator. Okay. What happened here? I got one negative value and one positive. BC, it shows me BC is positive, my DC is negative. I can go back there and change the direction. I can show this is DC and it is 4.0. This is that correct? That is 5.02. Any question? Question?
I was asking a question or something.
He was confused where we got the 4.09 from, because we solved it and then we found it on the calculator.
Did you use the calculator?
No.
No,
I
we saw that you used the calculator. That's how we
Remember,
found it.
even I solved this problem here, you should redo it, later on at home. If because sometimes you think you understood the problem, you can learn the process by doing yourself. You have to do it yourself. You have to practice. You have to redo it. Writing is very important. Learn by writing. Okay. So. So we got this two. Now we can go this one and this one. Right? We can start at this joint. Yes. Let's look at point D. Point D. We found that is going the other direction, so we have to draw it this way. And this is DC, right? This is point D. I'm gonna draw it, this is DB, right? And this is gonna be DA. Is that right? The free body diagram for joint D. I'm focusing on this one. So you can also draw, the angle. And this is 30. Which equation should I go? Should I go with the summation of moment? Is that valid? No. No, we cannot use summation of moment for joint. Only fx or fy. That was tricky, right? Fx 0, you can do this one. It's going this way, DC times cosine 30, dA minus dA cosine 30, 0. So we have DC, we got that one previously, 4.09 times cosine 30 dA cosine my dA is 4.0. Is it tension, compressive? I forgot to put, forces there.
Talking about point E.
It's going out, so it should be tension.
Yeah.
So Kn, and then tension. So, what else do we need to do at point D? We need to go for this equation, Fy. Fy 0. Fy 0 means we have the dA times sine, it's going downward sine, 30 minus, right? dC minus dC times sine 30. What else? We have dB. dB is going upward. So I have these two numbers, right? My dA is 4.09, sine 30 is half, minus dC is 4.09 times, half, plus dB, which is unknown. So when I solve this one, it's gonna be dB is 4.09. 4.09. Compressive or tension? Because I know the number I got is positive. Yes.
So when you have the minus dA cosine 30, does it cancel out the cosine 30s and that's how you get 4.89? Because
Yes.
otherwise,
If I take this one out this way, it's gonna be positive, right?
yeah.
Then either side, I have cosine 30, cancel them together, right?
Okay.
Then I'm left with dE and this one.
Okay. I was just making sure.
Yeah, good.
Thank you,
No magic.
Professor.
Okay, so I have dB and the positive, that means, this direction is correct. What does it represent? Tension or, compressive?
Tension.
Tension, right. Should be tension. Put no T here. So what else do we need to find? We have this one, right? We have this one, we have this, we have this. We don't have this one, probably it's gonna be the same as this one, but we need to, do it. So we can go to this point, or we can go to this point. So you decide which one you wanna pick. Let's go with point B. So again, draw the free body diagram for point B. This is 5.3, and then what was this one? I forgot. 4.0? No.
I think it's like 5.8.
It's 5.02.
5 point.
It was 02, I think.
That's it.
02. Okay. Was it compressive or tension? It was being compressive, right?
I think it was tension.
I thought it was tension.
I think it
No,
was-
no.
I drew it this way, so, and that represents compressive. So the value was correct.
Yeah, so it should be compressed.
So this is compressive.
Yeah, because it's moving.
Yes.
How do you know if it's under tension or just compressed?
how do I know whether it is compressive or tension? You know, draw the joint, right? You have to split. This is my part, this is the other joint, right? So this one, you know, these two forces, this is the joint, this is another joint. This is the member, right? What is the situation here? What is it, you know, tension or compressive? It's compressing, right? You know, it's shrinking. So shrinking means, you know, compressive. So once, you know, you have a part, you apply force, so it's going to compress the part.
It's just where the pressure is reacting.
Right? You know, whenever you have draw the two forces into each other, that means, you know, compressive force. Once you want to represent the tension, you have to draw the you know, arrow out toward outside. That means, you know, it's stretching, tension. So let me finish this one, then you are free to go. So this one was 500, this is 3. Yeah, maybe, I think, really, are they?
There's a couple waiting out there, but they're not like rushing in.
Okay, we can finish this one later in the next class. There is only one course. Okay, I'll see you on Thursday.
Professor, did you, put out
Yeah, it should be somewhere.
the